The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards, it's home demolition with a twist.
Fire in the hole!
A turkey goes up in smoke.
Now that is how you cook a turkey.
And Christmas time will never be the same.
There you go.
Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. We've all heard the story. You go on vacation and forget to turn the gas off to your furnace. The pilot light goes out and gas fills the room. When you come back into the house and turn the lights on, it sparks an explosion. Gas heaters are responsible for more than 3,500 structural fires every year in North America. We've got engineer Dan to explain how this happens.
The gas is fed into the unit where it meets a pilot light or a glow bar, which makes it burn up, heat comes out, and all the gases are then vented out. Where this can go wrong is if your pilot light goes out, that gas can just leak without burning into your home, or if somebody breaks the line, that gas is gonna leak into your home as well.
The team wants to show that this heater can blow up this room, and to make sure they do it right, they're first going to test out their theories on a dollhouse.
How much propane do we need to blow up the box?
Well, how big's the box? 4x4, right?
So we've got a 4x4 box. How tall is it?
4 feet.
Another 4 feet. That gives us 64 cubic feet. What's our explosive limit for propane?
4 to 5%.
When gas leaks into a room, all it takes is a 4% propane volume to ignite all the fuel trapped inside. This 4% is known as the stoichiometric ratio for a gas leak explosion.
Let's say we take 4% and we multiply that by 64, we're gonna get 2.56 cubic feet of propane is what we need to pump into that box so that it goes bye-bye.
The explosive limit is very low. Too much or too little natural gas and they won't get the results they want. An explosion.
Kate, propane is in.
The box is sealed.
Ignition system ready.
We want to be as precise as possible with the amount of propane we put in our box. That's why we've hooked this tank up to 2 different measurement systems. Up here, we have a flow meter that tells us the volume we've put in, and the tank is sitting on a scale that'll tell us the weight we've added. Here's the key. When this scale tells us we've added exactly 0.3 pounds of propane to our box, we'll let it circulate with the fans for about 10 minutes, then we hit the ignition.
Good? You guys ready?
Come back here.
Before this dollhouse demolition goes up in smoke, it's date night for Brendan and Dan. Hazardous enough. With their dates, the guys are going to show how a romantic evening at home can turn into one of the 370,000 house fires reported every year in the U.S. The guys are setting up an experiment with 2 heat sources found in practically every home: electricity and ethanol.
Get it all the way up. A guy like me loves an electric blanket because it's not too far away from being very, very dangerous.
Fondue's pretty simple. We've got ourselves some chocolate sauce that we're heating up with our element. I'm gonna start by filling up my fuel gel container.
Dan's fondue set heats up his chocolate sauce by burning an ethanol-based gel fuel from below. The fuel burns at temperatures around 200 degrees Celsius. Making matters worse, alcohol flames are difficult to see. The majority of injuries occur because people fill the containers while they're still lit.
Once it gets on you, it's gonna be very hard to get it off. Stop, drop, and roll isn't gonna help you. You're more likely to actually spread the flame. And if you try to use water, you're gonna spread it even more. That's how hazardous a fondue can be.
I'm taking a reading with my thermal camera, and this blanket currently reads about 38 degrees. That's hot, but I can make it a lot hotter.
All modern electric blankets have a safety to prevent them from getting too hot. This blanket uses a bimetallic strip thermostat. When electricity enters the safety, one metal expands faster than the other, bending the strip away from the circuit and stopping the electricity before the blanket overheats. Brendan is removing the safety to show how much heat a malfunctioning blanket can generate.
This is actually quite a simple thing to do. Don't do this.
So, because it's an alternating current. So I should cut it here and wire these three things together. Subvert the switch. That's exactly what I'm gonna do. Right.
Now what I'm doing is I'm gonna strip these wires and hotwire the whole system together.
I know Brendan's gonna do something to his electric blanket, so I'm gonna add more fuel. A lot more fuel. And then spill it on my date. This date is about to get much hotter than either of us anticipated. Hey, Brendan, how's your date going?
She seems fascinated.
I'm using this as it's supposed to be used, and it's already hazardous. You have to spend 10 minutes jerry-rigging yours to make it hazardous. Seriously, Brendan, how much more time do you need? I've been waiting for 10 minutes.
Just 2 more minutes, Dan. I'm nearly done.
Having finished rewiring the blanket, Brendan's next step is to concentrate the heat source by making a ball out of the blanket. An easy way to start a fire.
I think all my dates go better with alcohol. Any liquid with an electric blanket is not a good idea. In this case, a flammable one.
Oh, sweetie, look, you're making a mess.
Again, the alcohol makes for a far more hazardous scenario. Here, spilling a drink could actually cause the short in the electric blanket.
You've got a drinking problem, my dear.
With Brendan's blanket ready to warm up, this experiment is about to get too hot to handle. Brendan and Dan are comparing which heat source is more likely to make a date go up in flames. Dan has ethanol fuel gel that burns at around 200 degrees Celsius, and Brendan has recreated a malfunctioning electrical blanket by removing the safety.
Let's see whose date gets hotter. Go! 5 out of 6. 6 out of 6 lit, and nothing's happening.
This might take a little while.
Ooh.
Any second, all I need to do is tip this, and the hazard begins.
Well, it's getting hot enough to burn skin now, which is pretty hot.
I'm wedged between the 2 worst dates ever.
This is a hot date.
This is a very hot date.
Brendan, where are you at?
I'm 71, 72.
So it's gone up 30 degrees in like a minute.
It's hot. All right, this will go.
My chocolate is evaporating.
All right, she's at 90. We're getting somewhere anyway.
I see smoke coming off of her gorgeous dress.
My tray is literally starting to get really hot. I'm not actually gonna be able to tip it over if I wait too long. My date's hotter.
While Brendan's blanket is dangerously hot, Dan's alcohol is burning out of control. Once out of its container, the ethanol fuel gel spreads and clings to everything in its path. Even one drop can cause 2nd and 3rd degree burns from a fire that's difficult to extinguish. This proves that alcohol is truly the greater hazard.
Oh my gosh.
Right on. Yes. Right on. Ah, that's hot. Fondue, hazardous.
I have got to declare Dan the winner on that one.
God, I hate losing to Dan.
The hazard team has set up an experiment with a miniature house inside an acrylic box to see if they can recreate a gas leak explosion.
Good? You guys ready?
Come back here. Perfect, point 3. We're ready to go.
The box now contains a 4% propane-to-air mixture, the same conditions that kill hundreds of people every year. All Brendan needs to do now is hit the switch.
We're lit, and...
Nice!
You see, the concussive force just takes that wall right off the box.
Lifts the side of the house.
It's important to note that most of the explosion is on the lower part of the box, right? So our mix wasn't as good as we thought. Most of the propane still stayed on the bottom.
But still, it was enough to blow the box apart.
Absolutely.
So if we're trying to replicate what happens in a real home, we've sealed up the room nice and airtight. Maybe we can blow the room apart.
Now that the team knows what to expect, they're turning their focus to the bedroom to see how destructive a gas leak can be on a life-size scale. Unlike their miniature home, a real house contains leaks and holes that could easily allow air and gas to spread from room to room.
If we do this wrong and gas leaks out of this room, we could set the whole house on fire.
We need this house for future hazards. So to contain the blast, Brendan and Dan are making sure every surface in the room is covered with a plastic membrane.
Of course, Francesca's nowhere to be found.
Yeah, it's strange how she disappears whenever there's some real work to be done.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Christmas time, a magical season filled with joy and happiness, but also danger.
I wonder what it is.
Open it.
Right now?
Yeah.
Okay. You didn't have to get me.
It's not for me.
The hell is this?
You know it's not really Christmas, right?
Good morning, guys.
Dan?
Brendan. What? You guys started without me.
The team has created this scenario to test a hazard we all know well, a Christmas tree fire. This happens about 250 times a year in North America, killing more than 20 people annually. They've got an old dried-out tree, plenty of flammable wrapping paper, and Christmas lights glowing away.
One of my favorite tools is the infrared camera. With this, we can tell exactly what temperature different parts of the tree are, and not only that, it'll show it to us in a nice color scheme.
Even for a dry, dead tree, the needles on the branches must reach 232 degrees Celsius to burst into flame.
This one's definitely hotter.
But by how much?
Looking at 45 degrees Celsius. These aren't nearly hot enough.
And they've been on for a couple of hours.
Yeah.
So even if we left it all holidays, probably would never even get hot enough.
These lights alone aren't enough to ruin a holiday. But Christmas is more than just the tree. It's a roaring fire at the hearth, which we don't have. But Brendan has the next best thing.
Pile of hot embers and we'll blow the sparks
Brendan.
towards the Christmas tree. And this is a real hazard. This is the kind of thing that happens in the holidays.
Francesca is doing her best impersonation of a chimney, recreating a downdraft that could blow a burning ember onto the tree. So, to speed things up, Brendan is going to place the embers directly onto the tree.
Ready and go.
Oh,
That's going.
why does it sound like popcorn?
That's the pine needles you hear.
We're getting a lot of smoke in here, guys. Oh, look at all the smoke coming out.
Yeah.
Oh my God.
That is some black smoke.
Pouring out. That got serious really fast. The amount, it went from no smoke and just like a few pieces to boom, the whole thing went up and that room was filled with smoke.
Not only that, normally, I mean, we had people standing by, but your closest fire station is what, at least 3 minutes away? 3 minutes, that room is gone.
That's your house.
Gone.
A few hours later, the team returns to inspect the damage.
That is absolute devastation.
Look at all of the gear that's burnt away.
That was a big fire.
Do we have to pay for that?
No, I don't have to pay for this.
Not it.
Not it.
We did not expect this level of damage to our gear when we set the tree on fire. You can see this lighting fixture completely melted. Our blacks melted. There's a camera up here. Completely melted.
This huge amount of damage all happened in 45 seconds. Please do not underestimate the danger of having a dried out Christmas tree and embers close by from a fireplace.
A Christmas tree inferno is going to be a tough hazard to top, but the team is going to try. The hazard team has created an airtight room to trap the propane inside. Now, they're taking the final steps to make this massive hazard go live.
Propane is heavier than air, so it's gonna wanna sink to the bottom of the room. This inlet is gonna suck up that propane, then shoot it up throughout this exhaust, which will distribute it evenly throughout the room. I've also attached this rope to guarantee that this flue is not gonna move.
What makes a gas leak explosive is the introduction of a spark. Brendan is wiring an ignition source that's meant to simulate the effects of someone coming home to a gas-filled room and either lighting a match or switching on a faulty light fixture.
Ignition system is ready.
All right, fans ready too?
Okay, pilot light is out, heater turned on. Propane leak has started.
This huge propane tank is hooked up to our wall furnace upstairs, which is currently leaking propane into the room. The perfect stoichiometric ratio is 6.1 pounds of propane for that size of room.
Just like the miniature, Dan is measuring how much propane has been added to the room.
All right, guys, we're up to 1.2.
When the tank is 6.1 pounds lighter, the room will contain the exact amount of propane needed, and it'll be ready to ignite.
6. All right, 6.1. I'm plugging in the fan.
Fire in the hole!
This Thanksgiving, be grateful your house is still standing. Every holiday season, an estimated 4,300 fires occur, and the damages are tough to swallow.
Backyard turkey fry-ups are becoming increasingly popular. Most shows would tell you how to do it the right way. So of course, I'm gonna tell you how to do it horribly wrong. First, let's use a frozen turkey. Ew. Second, not a little bit of oil, way too much oil. Last but not least, this amazing contraption is so I can remotely drop the turkey from a safe distance. That way I can get maximum chaos and I'm not in danger.
Because the turkey is frozen, it's loaded with excess moisture. And we all know that water and oil don't mix. Especially when that oil is heated to its flash point. A massive grease fire might be enough fireworks for the holidays, but imagine what would happen if this fire burned through the gas line to the turkey fryer. Well, you don't have to imagine. We're going to show you.
Now that is how you cook a turkey.
The hazard team is recreating the worst-case scenario of a gas leak explosion. They've sealed up a room and filled it with 6 pounds of propane. Now, they're ready to hit the ignition.
You guys ready?
Sir.
All right. Fire in the hole!
Did you see how much of that house is gone? Wow, that was magnificent.
What this clearly demonstrates to me is that a propane leak is a very definite hazard. This was an explosion. This wasn't a fireball. In an unventilated area, when you contain that burning of propane gas, it explodes. It's a moving wall. That's what happened here.
Well, you can see the furnace came off the wall.
Yeah, most things came off the wall. The wall came off the wall.
This is by far the craziest thing that we've done yet.
We've ripped this house apart.
It's amazing. This was done by 6 pounds of propane.
6 pounds, that's about a third of what your normal barbecue takes.
And 1 spark.
1 spark, 6 pounds, gone.
And this is what happens.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards. A chili recipe with some major kick.
Well,
5-alarm chili.
A do-it-yourself melon massacre. And how flower power can leave your kitchen blowing in the wind.
1.
Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. These bags of all-purpose flour may seem harmless enough. After all, flour is the main ingredient in bread and cake. Who doesn't like bread and cake? But imagine you're in the kitchen. The burner on your stove is on high, and you're baking with flour when a bag accidentally bursts, causing a flammable cloud of dust. This type of reaction has caused dozens of explosions in North America and Europe, resulting in hundreds of deaths. How can this happen in your home? The Hazard team is about to show you.
Let's see what happens when I try and light this flour on fire.
Ooh, there we go.
well, that's not exactly the fire we were talking about, is it?
Still pretty flammable, though.
Some of it's burning, but it's only the top coat that has enough oxygen to react.
Let's make it airborne.
There you go. Unless you get enough oxygen to react with the flour, you're not gonna get that flashbang.
Dan's flashbang is the result of a perfect ratio. Flour is a fine dust made up of tiny particles, which are actually flammable. When these particles are mixed in an 8-to-1 ratio of oxygen to flour, they form the perfect dust cloud. By introducing a flame source, it causes a chain reaction, sparking every dust particle, creating a potentially explosive flash fire.
It has to be that perfect combination exposed to the flame. So we need the dust particle, we need oxygen, and we need an ignition source. And when all three of those things are perfectly aligned, that's when we get our flame. Wow!
The team will attempt to create a dust cloud big enough to fill the entire room using a common cooking appliance. But before they show you how this experiment can bake your whole kitchen, Dan and Brendan want to show you the most dangerous home reno jobs you can do on your own.
The guys are renovating the first floor bedroom. Brendan is painting and Dan's installing a ceiling fan. The question is, which is worse, paint fumes or ceiling fan?
That's it?
North Americans are crazy about doing their own home improvements. But one person is sent to the emergency room every 5 seconds doing the most mundane jobs. Now, Dan wants to show how doing this work near a spinning ceiling fan can knock you senseless.
This fan can get up to 20 miles per hour, and I'll be checking it with this radar gun. Our little watermelon Brendan is gonna saunter lightly right into the ceiling fan, chopping off his head. All right, Francesca, can I get the fan on?
Yeah.
All right, give me a second to get up to speed. All right, Francesca, I'm up to 20 miles an hour.
If you were changing a light bulb near one of these spinning fans, here's what would happen to you.
So that was it?
Hey, that hurts.
Not exactly the decapitation Dan was hoping for, but at 20 miles per hour, these blades are generating an impact force equivalent to 15 pounds, which is more than enough to knock out teeth and crush major veins and arteries in your neck.
As a tall person, I assure you that this was very painful.
Dan has shown us the consequences of getting your head caught in the spinning blades of a ceiling fan. Major headache. But Brendan wants to investigate something he thinks is way more hazardous.
Painting in a confined space where there's no ventilation is definitely a hazard.
He's going to demonstrate the hazards of spray paint fumes on the most basic level.
It's time to find out what cooked watermelon tastes like.
Paint is much more than just pigment. It contains volatile organic compounds, otherwise known as VOCs. These compounds are not only highly flammable, they've also been shown to cause cancer.
All right, Brendan, you've been torching for like a minute and a half. Think you've made your point. It works, but really, I mean, your paint's not even burning. It's really just your propellant.
Burns like these send more than 5,000 people to emergency rooms every year. Add an open flame, and it can easily inflict a third-degree burn that can permanently scar anyone's melon.
Please make paint fumes and ceiling fans as hazardous as possible.
We've seen how a ceiling fan can knock you senseless, and how paint fumes and fire can give you a wicked tan. But the guys want to ramp things up and show you the absolute worst-case scenarios.
Dan attempted to decapitate his mannequin with a ceiling fan and failed. Brendan burnt the side of his mannequin's face off and didn't even do that much damage. I have given them one final opportunity to make their items as hazardous as possible to see which is worse.
This is my murder fan.
In order to win the competition, Dan is going all out. He's replacing the ceiling fan's plastic blades with stainless steel aviator blades. He's also rigging the fan's motor to a variable frequency drive, so he can dial it up to the same speed as a high-powered industrial fan.
You know what, Watermelon Francesca, your hair looks good. Your teeth look incredible. It's gonna be okay. It's gonna be okay. All right, you ready?
All right, power on. Turning it up.
The blades are now spinning at a terrifying 3,000 RPM. And here's what it would look like if you were to walk into it head first.
Oh my God, that was so violent.
As the watermelon enters the fan, the twin blades deliver over 100 cuts per second. That's one way to make a fruit salad.
It's everywhere.
Chop the top of my melon head right off.
I'll give it to him. That was okay.
Oh, come on, that was spectacular.
I've got something better.
Now, Brendan wants to take his flammable paint scenario to the next level. He's using the same kind of paint fumes he used to cook his melon. But this time, he's filling the entire room and sealing it shut, recreating an accident that sends dozens of North Americans to burn units every year.
I'm just rigging up an ignition system.
What exactly are we looking at?
Danikin and Mancheska.
Yeah.
I filled this room full of oil paint fumes and thinner fumes. And they're all very, very flammable. And now I'm gonna blow it up.
You actually think that this is gonna be worse than my 3,000 RPM murder fan?
I think there's only one real way to find out, and that's by me pushing the button.
Believe it or not, people have actually leveled their houses making the same stupid mistake. Here's why paint fumes and fire shouldn't be mixed.
3, 2, 1!
That is a fire, and that was a boom.
Now, that's one bathroom you wouldn't want to light a match in. The Hazard team has created a flash fire using all-purpose flour. Now, they want to see if this standard kitchen mixer can create an airborne cloud of flour big enough to light the entire kitchen on fire.
All right, here we go.
They hope the beater blades on this mixer will stir up enough flour to create a cloud of flammable dust.
We do get...
A little bit. I can see it in the foreground.
There you go.
The mixer is kicking up a flammable cloud of dust directly above the bowl. But it's not enough to set the room on fire. For that, they're going to need a much more powerful appliance to get the flour circulating.
All right, so clearly flour is flammable, but how can we maximize the hazard?
I say we do what we did and just make it bigger. More fire, more flour.
Huge industrial fans on both sides to just push all the flour right onto the flames.
High-powered fans like these make sense in any hot kitchen.
Large fan coming through.
By aiming them at the ceiling, they should suck all the flour off the table and into the air, creating a cloud of dust.
All right, I think we're done.
All right, blow torches on, let's get out.
Once that cloud comes in contact with the open flames, it should be goodbye kitchen.
You gonna hit it? You ready? 3, 2, 1.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The pressure cooker. Once found only on the bottom shelves of your grandma's kitchen cupboard, the sales of this device have recently skyrocketed. So have their pressurized lids. The Hazard team has set up a cook-off to test this device that seriously injures hundreds of people every year.
You're the chili king, are you not?
I make a mean chili.
Over 50% of pressure cooker-related injuries involved explosions or liquid bursting out of the pressure cooker.
There's more meat.
Francesca and Brendan are making some chili to test the hazards of a pressure cooker. Anyone who's used a pressure cooker knows that they're dangerous.
It is great. It's the best chili ever.
What makes a pressure cooker different than a normal pot is the sealed lid. As the temperature inside the cooker rises, the molecules move and expand with nowhere to go, creating enough pressure to raise the boiling point of water from 100 degrees to 120 degrees Celsius. The only safety mechanism on this pot is the steam release on the lid, which kicks in when the pressure rises above 15 psi. Any more than that, and the cooker can explode.
If any of the safety mechanisms on this device are compromised, you can have a very messy situation.
So you can see the pressure cooker is venting off steam,
Yep.
which means that it's maintaining its 15 psi, 121 degrees Celsius. This is still hazardous, though.
We have something under pressure that's above boiling.
If we made it improperly maintained, or a pressure cooker that's got a faulty safety valve,
If the steam valve is compromised, no steam is going to be released.
or somehow we're able to open the pressure vessel while it's still under pressure, then that could be pretty dangerous.
Human error aside, it's a dangerous tool in the kitchen, and I think people underestimate it.
Should we go check on it?
Yeah.
Let's open it.
Whoa! You can't open it while it's on, its contents under pressure. There's a reason there's a safety lock on it. If you're gonna open it, I'm gonna be nowhere near it.
Okay, I've got some safety gear. I'll put some safety
Terrible
gear
idea.
Modern pressure cookers have a lock that prevents you from opening them while cooking. But that's not stopping Brendan from forcing it open, recreating how many of these injuries occur.
Our pressure cooker had a maximum pressure of 15 psi. It's a good thing Brendan was wearing his protective gear. When he ripped that lid off, you could see the steam and the pressure just come flying out. Now let's see what happens when we disengage the safety mechanism.
Francesca is sealing up the vent holes to replicate an unwashed pressure cooker that's had its steam release clogged by crusty food.
What I've done is removed the steam release. I'm filling both of the holes and sealing them shut so that no steam can escape.
As the pressure builds inside the cooker, it has no way to escape. And with no way to escape, there's only one thing that can happen.
Well,
That is some explosive chili. 5-alarm chili.
that's a new recipe for me.
Definitely don't want that to happen in your kitchen.
No. Look how far it flew.
Cool, it looks deformed.
Yeah, it had a rough half hour.
We're lucky we were doing this outside. Can you imagine if you were enclosed in your kitchen?
That would be, not good. If you contain pressure in any vessel, it will eventually find the weak part, the fault. In this case, it happened to be the lid. When the pressure became too much, that's where the lid went.
Normally, a pressure cooker is hazardous. You've got steam and pressure. But if your safety mechanisms ever get gunked up, you've essentially got a bomb.
I'm not going to eat chili for a very, very long time.
The Hazard team wants to show how a cloud of flour can create a violent flash fire that could bake your kitchen to a crisp.
All right, here we go.
They've already tried using a stand mixer, but it failed to stir up a big enough cloud.
Large fan coming through.
Now, they're hoping these high-powered fans will deliver the kind of turbulence they need.
3, 2, 1.
They've pointed the fans at the ceiling so that they suck up all the flour on the table and disperse it through the room. If it works, these candles will spark a chain reaction that will cause a fireball. But not only are the fans failing to disperse the flour, they're actually putting the candles out.
It's not gonna work.
To make this experiment work, the team needs a stronger flame source and a way to fill the room with all the flour all at once.
We need a huge cloud of flour. What if we had an air compressor?
Well, we could use the air cannon.
That way we can load all of the flour in, a burst of wind that will push the flour airborne. The only thing we need is a flame source that won't go out.
We need a mean propane torch. Like the same thing you'd use in like a barbecue, essentially.
Mm-hmm.
You want a tiger torch?
Yeah.
For a dust cloud to violently combust, the team needs that 8-to-1 ratio of oxygen to flour that makes ignition possible.
I just want to make sure that it's high enough that when it shoots the flour out, it lands in the middle of the room.
Based on the measurements of this kitchen, They're filling the funnel of this air cannon with a 10-kilogram bag of flour, hoping that will do the trick. The team is also bringing in this heavy-duty pressurized gas torch, so powerful that even the cannon won't extinguish its flame. This air cannon has a tank of oxygen pressurized to 60 psi and is hooked up to a funnel filled with flour. When the team triggers the cannon, it will release a burst of air, forcing the flour out of the funnel, where it will pass through the flame of the torch, sparking a violent flash fire.
Frankie, can you turn the gas on?
Got it. All the way open.
Thank you. Let's get out of here. Ready?
Yeah.
Get the trigger.
In 3, 2, 1.
Road collisions account for only 3% of vehicle fires,
You think it's dangerous to drive? What about parking?
which means the other 97% happen when your car isn't moving at all.
Brendan, what are you doing? Come in the house.
Actually, you should come to the bomb shelter.
Brendan wants to recreate what happens if you come home and park your car over something that's already on fire, like a pile of burning leaves.
You should actually come to the bomb shelter right now. Like now.
What are you
like
talking-
now. Like
Brendan!
now.
The car's gas tank is nearly empty, which you'd think would make this far less hazardous. But think again. The fumes inside the tank are far more volatile than gasoline in liquid form. When exposed to an open flame, great balls of fire. While the firefighters extinguish the inferno, the hazard team is ready to take their flour cloud experiment to the next level. They've filled a pressurized air cannon with all-purpose flour and aimed it at an industrial-strength torch to show you how a dust cloud can leave your kitchen in ashes.
Get the trigger.
Yes, sir.
The flame is hot and ready. Now all Dan has to do is trigger the air cannon.
3, 2, 1.
This flash fire isn't just igniting the flour in the room, it's burning up all the oxygen, too. If you're unlucky enough to get caught in its wake, your lungs would fill instantly with burning hot flames that would leave you breathless, permanently.
There's a flash of flames, bit of smoke, and it's like it never happened.
Can we go check it out?
Yeah, let's go. Oh, wow, it's all over the wall.
The amount of damage that happened in a few seconds is unbelievable.
Where the cannon actually shot stuff onto the wall, there's really heavier marks. What's terrifying about this situation is that the fuel for this fire was something as innocent as flour. Something that you bake with every day. Something that's in every single kitchen throughout the world. When you get a cloud of flour like that, you don't know what could happen, especially when there's an ignition source. This is a serious home hazard.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards,
Car airbag.
the team crash tests a microwave. Francesca gives an explosive lesson in art.
That's one way to paint a canvas.
And a bedroom takes a bath.
Drop it! All right, here it comes!
Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Everyone enjoys the luxury of a nice, relaxing bath. But behind the walls and beneath the floor of this oasis lies the potential for a real disaster.
We've all heard stories about a bathtub crashing through the floor. What we're going to test today is how hazardous a situation is this really?
It sounds like a freak accident, but it's a recurring one. Every year, there's at least one news report of an unsuspecting victim who draws a bath only to travel with their tub through the floor the minute they step in. And their prime suspect is water damage, a problem that costs homeowners $11 billion a year in the U.S.
Brendan, I'm getting close here. It's gonna overflow.
Well, that's the hope, so keep going.
Full and occupied, a bathtub is like an 800-pound anvil suspended in midair. And all that's holding it up are joists and beams that, if damaged, could threaten the lives of whomever's in the tub, as well as any unsuspecting people sitting below.
They're doing something hazardous without me. I'm very upset. What are you guys doing?
We're trying to simulate rot to try and recreate a scenario where a bathtub would fall through the ceiling.
You guys are gonna be here forever. Do you realize how long it takes for the wood to rot? We need to see what the beams look like, figure out how much actual support this thing has.
All right, let's get to work.
Water can begin to damage a home within 48 to 72 hours. But an average bathroom like this one is built to support more than 2,000 pounds, meaning it could take months, years, or even decades to turn deadly.
Oh, and careful, Dan, she sprays everywhere.
Yeah, you're spraying me right now.
What the team doesn't know is how bad the damage already is, and if there are any other factors making this hazard more likely. As soon as the wall's exposed, the team spots examples of questionable construction.
They did compromise these joists by putting the pipe through it.
But if you look here, this bathtub is supposed to be screwed through into these joists, and it's not.
Most people believe a tub is only held up by what's underneath. But a bathtub, properly constructed and installed, is supported from below and from the sides, sharing the load. If one support goes away, that doubles the load on the other. With nothing but putty attaching the bathtub to the wall, all the weight is on the joists below. And if those are in poor condition, then this bathtub could well be on its way to disaster.
Now we're taking up the subfloor, so we know what we have to do to put this tub through the floor. Huh. What do you think?
This does not look good.
Looks like it's time for a serious investigation. But first, the hazard team is mixing it up with one of the kitchen's most dangerous appliances.
You both get a blender, because today we're going to explore which is worse, blender splash or blender chop.
Blender chop and the splash.
Blenders are one of the kitchen's most powerful tools of convenience, but they've also sent 40,000 North Americans to the ER over the last 14 years. The hazard starts with the sharp metal blades. Spinning at speeds of up to 38,000 RPM, they can chop and shred anything put inside. Above the blades is the pitcher, which helps circulate the blender's contents. But if the lid is missing, there's nothing to stop what's inside from splashing out. So, which one causes more harm? Blender chop or blender splash? Putting your hand inside a blender is a foolish thing to do. But when ice or a kid's toy ends up creating a jam, some people think it's a good idea to use their hands to get the blades going again.
You jammed this thing and you put your hand in there to try and get it loose. Before you know it, you'll have lost the digits on your hand.
To recreate this dismemberment, Brendan is stuffing the blender with toys, a familiar scene for those with toddlers running around. But instead of a child's hand, Brendan is using a pig's foot.
Because this simulates a human hand, the flesh and the bone, and you'll see what kind of damage this blender can really do. That seems properly jammed.
Sure, the spinning blades of a blender are dangerous, but everybody knows not to put their hand in it, or at least to turn off the power before you do. I'm gonna start heating up my soup.
Meanwhile, Dan is cooking up some hot soup he plans to puree. And that, too, is the beginning of a horrific hazard.
People always forget to put the lid on properly on a blender, and it splashes everywhere.
If that splash is hot enough, anyone peeking in to check if the soup's done could end up with a third-degree burn, scarring them for life. Exactly why Dan's using a gelatin head instead of his face. It melts at the same temperature as human skin, 60 degrees Celsius, which Dan's soup is almost up to.
Guys, can we bring in the protective glass? Let's put it right here. That's all the way. We're putting up a sheet of clear plastic to protect Dan and I when we run this, because we don't want to get hit by glass shrapnel or hot flying soup. Thanks, guys. That's great. That's perfect. Hey, Dan, how you coming?
Soup's coming along. Hot stuff. Now all I've got to do is fill my blender with soup and turn it on.
All right, you ready?
Ready?
I've got this trigger. I'm gonna make both machines go at the same time. Then we'll see what happens to our pig's foot and our gelatin head. Let's do this. In 3, 2, 1.
Brendan and Dan have set up their blenders and are ready to test which is worse. Injuries caused by a blender's spinning blade, or the scalding hot liquids that get put inside.
You ready, Dan?
Yes, sir.
In 3, 2, 1.
Face got splashed.
It's easy to see how quickly a blender can turn into a devastating hazard. In only milliseconds, the blade severs the outer flesh and tendons of the pig's foot. The same blades instantly create a vortex, which carries the soup up so fast, no one would have a chance to get out of the way.
That's what happened to my pig's foot. If this had been your hand, you would be very unhappy.
Well, if you have a look here, you see that the gelatin head got hit straight on by some really boiling hot soup. And it started to actually melt the gelatin head, which means if this was your face, you'd have third-degree burns.
All right, what do we have here?
You've got almost severed digits and third-degree burns.
Oh my gosh.
You can see some of those are pretty deep.
Though both are hazardous in their own way, I've got to declare Brendan the winner on this one. If that was your hand, your fingers would be shredded to nothing.
Whether you're inspecting soup or have a hand in the blender, it doesn't take a lot of brain power to avoid these injuries by making sure the lid is on or the power is off. But for a child who doesn't know better, it wouldn't take much to get burned or lose a finger.
The proof is in the pig's foot.
But some hazards aren't quite so obvious, even if they're equally terrifying. The hazard team is on the hunt for signs their bathtub is ready to fall through the floor. They don't like what they've found so far.
This bathtub is supposed to be screwed through into these joists, and it's not.
The only thing holding up the tub is the floor, and if it's in the same shape as the wall, it's in trouble.
This does not look good at all.
You can see when they ran this pipe, they've cut through and compromised these floor joists.
You can see all around the tub, the water has soaked through time and time again.
Basically, every time your bathtub overflows, you don't realize it, but in that water, it's actually going into your floor and it's starting to make that rot.
You know, and you can see it's cracked here.
Worse than that, this one actually split and it runs for about 10 feet of split. That is a really, really weak beam.
We can say that without us doing anything yet, this is not a good scene.
With all these problems, it's only a matter of time until this tub puts someone's life in jeopardy. But the team wants to know what happens when it does.
So, can we help it along a little bit?
Let's just fast forward.
And by fast forward, Francesca means years of water damage, so our dummy can get his last splash. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. We often wonder if something is hazardous, but that's not the case with the microwave, an appliance that 90% of us own. Deep down, we all think it's a little dangerous.
The microwave. Some consider it to be the largest convenience ever introduced to the kitchen. But if you put something in the microwave you shouldn't, you can have a very hazardous situation.
A microwave oven heats food up by shooting electromagnetic radiation through it, exciting its molecules, which release their energy as heat, warming up your dinner.
Eggs.
Eggs. Thank you.
But if the energy gets trapped, like a steaming egg inside its shell, eventually it will find a way out.
Oh!
Any way it can.
Ooh!
Parents worry that microwaves are potential killers because of outcomes like this. But Brendan and Dan are about to prove that the real danger isn't the microwave, it's what people, either for fun or out of sheer stupidity, decide to put in it.
Some light bulbs.
Brendan and Dan are planning to push the limits of what shouldn't go into a microwave.
Pop them all in.
All right, pop them all in.
A whole bunch.
5 minutes.
5 minutes.
Start cooking. I think they're all going.
It's like Christmas.
Inside the fluorescent bulbs, the microwaves are exciting the mercury vapor, causing them to illuminate.
You smell that?
I do.
That's dangerous. Turn it off. Let's go.
What was the smell?
We definitely had some ozone that was created anytime that metal arcs in a microwave.
And is that poisonous?
Yes. If one of the compact fluorescents broke, those little twirly ones, we could have been inhaling some mercury vapors.
That would be bad.
Yes.
It's obvious to most that light bulbs in a microwave is a bad idea. But it's surprising how often the wrong thing finds its way inside a microwave, like aluminum foil.
I want to see the potatoes next.
Baked potato.
Baked potato.
Tin foil?
Tin foil.
Can't bake a potato without tin foil.
Metal is often used inside food packaging, which many people overlook. It's a mistake that contributes to 5% of all cooking fires.
How many do you want to put in?
I want to put in like a good half dozen.
I'm down with that. In. 5 minutes. 1, 2, 3, go. Oh, go.
Yes!
Well, that didn't take long. Did you see the plasma?
Oh,
Whoa.
there's one. That in the corner there is actual plasma trapped.
Molecules of metal are densely packed in a solid state. Like food, they gain energy from microwaves, but they are unable to move, forcing energy to build up. This superheats the metal and converts it to plasma, the hottest and most dangerous state of matter. Believe it or not, this is the same reaction that takes place on the sun.
So, baked potatoes wrapped in tin foil are meant for the barbecue, not the microwave. Do you want to put something else in?
Definitely.
We've seen that some objects in the microwave can cause sparks and flame, but how about an explosion? For that, Brendan has an over-the-top plan to show what it would really take to make something like this happen.
What took you so long?
Car airbag.
What? Okay, you want to put an airbag inside the microwave?
Yes, I do.
You know, this packs a mean punch.
Yeah.
Microwaves only explode when explosive materials are put inside, and the airbag uses a small charge to inflate its contents. Brendan is hoping sparks from the metal will be enough to detonate this device, just like it would in a car.
We don't know where the door is going to go. We don't know where the microwave is going to go. So this is my remote control finger.
You, sir, are an artist. All right?
Excellent.
All right, airbag's in.
Are you ready?
Ready?
On 3?
On 3.
3, 2, 1.
That microwave's completely deformed. The entire cage has been ruptured.
It only took 11 seconds to trigger the explosion, but when it did, the airbag expanded at 200 miles an hour. And this is where the true danger of a microwave lies. When you put something explosive inside, it's like putting a match to a stick of dynamite. Back in the bathroom, the team is making the final preparations needed to crash their bathtub through the floor and learn how hazardous this can be. Once compromised, it's impossible to know how much this floor can hold.
This does not look good at all.
And at close to 800 pounds when full, the bathtub is the most dangerous place a person can be. One step inside could be all it takes to break the beams once and for all.
We are simulating years and years of poor workmanship and water damage by attacking every single support to that bathtub. When you spill a little bit of water on your bathroom floor or when you cut through a joist, most people don't think about it, but you could be adding up to a very hazardous scenario.
With the beams ready to snap, there's still one more element necessary to make this hazard a real possibility. Someone needs to take a bath.
Yeah, we're hanging him by his neck.
The team is rigging the mannequin to a quick release so they can easily send him into the compromised tub from a safe distance.
More weight.
Saddled with 200 pounds, the mannequin now weighs as much as an everyday person.
The worst part of the scenario is that not only is the bathroom hazardous, but whatever room is below is also in great danger. If you had somebody sleeping down here or maybe kids playing, you've got 600 pounds of metal tub that is about to crash through the ceiling. Very hazardous.
To stay ahead of the curve, artists are always looking for ways to stand out. And Francesca is going to demonstrate one colorful method of exploding onto the scene. Accounting for 19% of all aerosol injuries in the US, spray paint is the most dangerous aerosol product on the market. It's dangerous in two ways. Its contents are under pressure, and those same contents are flammable. So when put beside a heat source like a stove or a radiator, this simple can might just turn into a grenade. As the paint heats up, the gas is expanding inside, looking for a way out. And Francesca's hoping for a bullseye. Total destruction. If this was in someone's hand when it exploded, it would definitely be their last masterpiece.
That's one way to paint a canvas.
Hovering over the bathtub hangs a 200-pound mannequin, ready to recreate a hazard homeowners pray never happens to them.
You might want to stand back from the tub just a little bit. Yeah, we kind of compromised the subfloor.
And just like a person slipping into a bath, the mannequin will be the extra weight needed to send our bathtub through the floor.
When that bathtub goes, I don't want to be in the bathroom, and I definitely don't want to be underneath the bathtub. I'm going to be in the room, but I'm going to be over there.
Dan, you ready?
Yeah, drop it!
All right, here it comes. And 3, 2, 1, go! Well, that works.
I think it worked!
You think?
Yeah! If I'd been standing here, I'd be dead.
Did the tub fall through straight, or did it turn on an angle right away?
The ceiling held it for a millisecond and then just vomited all over the room.
Unbelievable.
Yeah, you can see all the water damage in the drywall.
That's electrical.
And this electrical that I've been very much avoiding. This cut clean through, and we've got a live wire sticking in our bedroom. That is a very big hazard.
This happens. People remove retaining walls. They run the plumbing the wrong way.
Maintain the structural integrity in your home, and don't let shoddy handymen cut through your beams.
I'm confident I will never take a bath again, especially not in this house.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards. The team unleashes a gardening nightmare.
This thing is a huge hazard.
Brendan's doppelganger feels the heat.
Burn, dummy Brendan, burn!
And an uninvited guest crashes a dinner party. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The automobile. Every year, 1.2 million people die in crashes worldwide. And hundreds of accidents involve cars crashing into homes. And in most cases, it's because of one simple mistake. The driver failed to step on the brakes in time to avoid a collision. The hazard team wants to find out what kind of damage a car can do to your home. First, they're setting up an experiment to test their brakes.
35, 36, 37, 36, 35.
Oh!
And stop.
Driving at 50 kilometers per hour, the team wanted to see if Brendan could come to a safe stop after slamming on the brakes.
So what do you think?
It was pretty good.
Braking distance on dry pavement depends on the speed of the vehicle. At 50 kilometers per hour, it only took Brendan 9 meters to stop. But at speeds over 55 kilometers per hour, stopping distance increases dramatically.
So why don't we take this car to 40 miles an hour, I will hit the brakes, and we will see how far I travel.
Let's see it.
Okay.
Ideally, Brendan has exactly the right amount of space he needs to stop completely. But we're gonna see how hazardous it is to try and brake on a dime.
40 miles an hour is approximately 65 kilometers per hour. And at this high speed, Brendan has to accurately judge the distance he needs to bring his truck to a stop. To make things interesting, Francesca and Dan have set up a pane of glass just past the stop line, representing the living room window of a suburban home.
All right, Brendan, take two, floor it.
36, 37, 40, 42. Holding at 42, 43.
But before the team shows you what damage a car can do to a real house, Brendan is going to test out the lawnmower, a hazard that sends 80,000 Americans to the ER every year.
It's a beautiful day to be in the backyard running things over with my lawnmower. And by the way, lawnmower, serious hazard.
Designed like a propeller engine, the lawnmower uses torque to spin a sharp horizontal blade at approximately 3,000 revolutions per minute. Perfect for shredding through light objects.
Where the hell did he find that ball?
Which Brendan's going to demonstrate by mowing over a few examples.
What, he's been going through the garbage? Completely chewed up. Whoa, 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 whoa! No, no, no! If you're gonna push this hazard this far, I want to be able to appreciate the destruction.
If you run over it like this, we're gonna miss everything that happens.
Yeah, all the good stuff is under there.
Okay, how do we do that?
Give us a second, and we're gonna rig something up so we can watch the chaos that happens when you run over stuff.
He likes to mess things up, but I want to understand why they're getting messed up and how. That's why we got to take this hazard to a new level.
As strong as it is, the lawnmower can't cut through everything. But what it doesn't cut, it can propel at 320 kilometers an hour towards anyone standing in the line of fire.
You got some debris for me?
Exactly why you're supposed to check for hard objects before cutting the grass.
Awesome.
In this pile, we have all sorts of debris that's gonna go flying. We have kids' toys, marbles, rocks, all things that when they go airborne, pretty dangerous. I'm excited.
All right, we're good to go, Brendan.
All right, I'll start the mower.
Let's do it!
Yeah.
6 meters away from the lawnmower, the team has set up a wall of glass jars, which, when full, are stronger than your skull.
All right, here I go!
Okay. Yes!
This is what could happen when you run over something light enough to be propelled, but hard enough to kill. It only takes one rock, and someone's life could be at stake.
Well,
That is rough.
that's awesome.
Well, we destroyed a good, like, dozen or 2 dozen jars.
And I think one lawnmower. So the lawnmower is a hazard.
You think?
Do you think that was not a big stretch in the beginning? Like we were gonna get lawnmower hazard? I think so.
Well, we saw that shooting stuff out can be hazardous, but I've got one thing that's gonna make this look like preschool. All right, I agree that projectiles in a lawnmower, very scary. What I'm afraid of is the blade flying off.
Yeah.
I've released this blade, I've taken out all the notches that keep it on the drive shaft. And then I rigged this quick release. So whenever I get the blade spinning, I can just fire it off.
Corrosion and poor maintenance can actually cause lawnmowers to release their blades. And Dan is going to test this hazard by setting up a potential bloodbath in the backyard. The team is testing how hazardous a lawnmower can be, and they've designed a scenario to show the damage a loose blade can cause. Dan has rigged the mower's blade to a remote quick release so that he can remain behind the safety shield when it spins off. This is so dangerous, the team has no way of knowing where the blade might fly.
All right! All right! And on!
Whoa!
Oh, yeah.
Really? Yes?
What happened?
It actually went that way instead of that way, so really unpredictable. And look how much power it hit with. It actually bent the blade.
That's unbelievable. You know what? You got it to fly off while it was running, and that just confirms how hazardous we thought it was.
So where did it hit?
It actually hit right behind your head. It just goes to show you, you can't predict where these things are gonna fly off.
Definitely not.
But there's one hazard you can always predict: human stupidity. And when it comes to the lawnmower, it's the most hazardous of all, even though it could be entirely avoided.
Hey, Brendan, we're in position.
It only takes a second to drive over your foot with a lawnmower, which is why Brendan is using a pig's foot to simulate the carnage that happens when a human appendage gets caught in the blades.
Are you guys ready? Ready! And 3, 2, 1.
Oh, there's pig leg shavings everywhere.
You go.
That was insane.
Okay, that's gross.
It shaved pig flesh all across the yard. Look at it. This thing is a huge hazard.
No doubt about that. This is an injury that requires amputation 95% of the time. So you might want to pay attention to where you put your toes. The hazard team is testing the forces behind a vehicle plowing into a house. They've set up a pane of glass on a paved road and asked Brendan to bring his truck to a complete stop while going over 65 kilometers an hour.
All right, Brendan, floor it!
The higher the speed, the greater the braking distance, and the harder it will be to judge when to hit the brakes and avoid smashing into the glass.
36, 37, 40, 42. Holding at 42, 43.
Driving at full tilt, Brendan slams on the brakes, but fails to stop in time. If this were a house, Brendan's truck would be inside the living room.
Was that enough braking room?
I'm gonna go with no. What was that like?
That was fun. I'll do that again.
Just a small increase in speed made a huge difference in stopping distance.
Now that we know how this could happen, the hazard team wants to find out just how much damage it could do to a home.
Let's go check out a spot where we can do it.
Okay.
But before the team shows you what damage a car can do to a real house, Francesca's cooking up another hazard in the kitchen. The modern electric toaster. Fast, convenient, and in 2008, deadly. Killing 791 people and making it one of the most fatal appliances you can have in your home.
Anything that can take an innocent piece of bread like this and turn it into a piece of charcoal like this is definitely a hazard.
A toaster is essentially a box with a heating element inside. When the lever is pushed down, electricity is allowed to flow through metallic elements made from resistor wires, which then radiate heat into whatever is put inside. Toasters may be a common appliance, but remember, they're designed to burn things, which means if you put something flammable in the toaster, like butter or oil, you could light a fire. Exactly what Francesca's about to try.
What do you got going on here?
I set up this mannequin to replace myself. I've got a gelatin hand waiting atop of the toaster. I want to see just how dangerous a toaster is when you're making toast.
Oh,
Getting smoke.
Within seconds, the coils inside have heated up to 650 degrees, 300 degrees hotter than the flash point of olive oil. If one drop of oil touches the wires, the toast could instantly ignite.
Okay, well, it works.
We definitely have a toaster fire.
Even with less oil than used here, buildup over time can easily spark a deadly fire. Never put oil in a toaster.
And it's gone.
See, even the mannequin knows to take their hand off a burning toaster.
Burning plastic. I'm out of here.
This is pretty hazardous. You think you can do better?
Yeah, I think I can do better than that.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Francesca has shown that buttering your bread before putting it in the toaster could result in a very hot breakfast. But Dan thinks the toaster has a far deadlier hazard card to play. When the toaster was first brought to market, it was one of the first appliances to come with a warning label in every box. And there's a reason why. Electrocution.
To show you how dangerous this is, I'm gonna do what everybody knows you should never do. Stick a knife into a toaster. Since I want uninterruptible power for this, and the house's power supply has some safeties built into it, I'm gonna use these car batteries.
Just like Francesca's experiment, Dan is using a gelatin hand with resistor wires put inside, which are designed to conduct inefficiently and turn current into heat, showing how electricity can move through the body.
In order to understand an electrocution, it's important to know the difference between volts and amps. If we think of an electrical current as a waterfall, the height of the waterfall would be the volts, and the amount of water falling would be the amps. That's why it's better to get hit with, say, 15,000 volts and 0.1 amps, like a raindrop falling from really, really high, instead of getting hit with 120 volts and 20 amps, kind of like a swimming pool falling on your head.
Dan's 2 car batteries are each only 12 volts, but the toaster will draw from them as much as 13 amps.
Here we go.
Less than the standard capacity of a kitchen power outlet, but more than enough to cause a severe electrocution.
Oh, you see that?
Oh, wow.
Oh, it's melting right through.
That's great. Well, quite clearly, there's an electrical current traveling through Dan's ballistics gel hand.
This is what happens to you when you get electrocuted. You're literally frying from the inside out.
Yeah, if you got your hand in there, and if you were being electrocuted, you could not let go. All your muscles would clench up, and this is what happens. I always enjoy a really good fire, but I have to say, electrocution wins.
Nothing is more common than a toaster. Something really innocent, but it can do this.
Breakfast never looks so dangerous. But lucky for us, it's nothing compared to dinner time back at the house. The hazard team's testing how bad the damage could be if a car rams directly into a house. To prepare, they're building a ramp aimed right at the house, and they're swapping out the truck for a stunt car. All to make it safe for one person, the professional stunt driver.
So here's what's gonna happen. Our car's sitting 150 feet away. It's gonna get up to 35 miles per hour, hit the ramp, go through the patio doors, and go crashing into the dining room. Let's see how our house stands up to a car crash.
In most of the team's experiments, they remove a lot of safeties to make a hazard happen. But this time, there's no safety to protect this home from a 1.5-ton projectile. So to demonstrate just how shocking this accident can be, the team has prepared a perfect dinner party for the stuntman to crash.
The key thing is you need to hit the ramp straight on. Also, since the house is in such bad shape right now, we're gonna have about 200 feet of rope tied to your bumper so we can pull you out if the house collapses. Good luck.
With dinner set and the engine hot, the team's crash test is ready to go.
In 3, 2.
But before the stuntman puts his pedal to the metal, Brendan wants to test a real hazard that could happen to any wannabe handyman. Some hazards happen so fast it's impossible to get far enough away. That's why Brendan's using a dummy for this next hazard. He doesn't want to be anywhere nearby.
Propane is used by over 8 million people in North America, but it doesn't take a dummy to know that this is dangerous stuff. These little babies cost us over $29 million in property damage every year. That's an expensive barbecue.
The hazard team has already shown that a propane canister has a safety built in, allowing gas to be released slowly so it doesn't explode. Even an empty container can be explosive if the safety is bypassed, which is what Brendan's about to demonstrate. He's going to drop an oxyacetylene welding torch next to a propane tank. Exactly the kind of scenario that could play itself out in garages everywhere.
It's time for this dummy to burn that dummy.
A gas welding torch like this one burns close to 4,000 degrees and can cut through steel almost instantly. Meaning, if this situation happened by accident, you'd have only seconds to react.
Burn, dummy Brendan, burn!
Propane tanks might seem relatively safe, but you'd be a dummy not to take them seriously.
There's only room for one Brendan. It wasn't him.
The team is investigating what kind of damage a car can inflict when it crashes into a home. 45 meters away is a car with a stunt driver ready to roll at 55 kilometers an hour towards the house. Inside is a family's worst nightmare, a typical Sunday dinner lying directly in the path of destruction, without a clue as to what's about to happen. Now all this experiment needs is a little bit of gas.
All right, in 3, 2, 1, go!
Well, that ruined dinner.
Stuntman, are you okay?
You know what? That guy's okay.
Check out the damage.
Well, dinner's gone.
Yeah.
Unbelievable.
This made a huge mess of our dining room.
As we saw earlier, the faster you go, the greater the distance needed to stop safely. Even though the car was traveling at only 56 kilometers an hour, the devastation still hits home. Anyone sitting down for dinner would have no chance to avoid this life-threatening disaster.
At least this room's bigger than the garage. Maybe we should keep the car in here.
I think that's a good idea.
It's a nice addition.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards, how your home reno
This is the hazard in this room.
can become a home demo, furniture that can set itself on fire, and a hot tub party you won't want to miss. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. We've all heard the story of that home renovation project that went horribly wrong. It starts with trying to turn 2 smaller rooms into 1 open space. The only things standing in your way are a couple of useless walls. But how useless are they?
See, this is the thing that's hazardous about doing home renos. You never know what's behind the wall.
Agreed, there was a mirror inside the wall.
The Hazard team wants to show you how removing a load-bearing wall during your next home renovation project could leave you without a roof over your head. The walls you don't want to mess with are the load-bearing walls, which support the structure above by transferring the weight of the roof down into the foundation. If you were to accidentally remove a load-bearing wall, you could cause your entire house to collapse. Walls that run perpendicular to ceiling joists are usually load-bearing and can be spotted from the attic. But this really should be determined by a professional. Of course, there is another way to see if a wall is load-bearing, and the team's gonna try it on this one.
If we rip it out and the room collapses, it's probably a load-bearing wall.
We wrap a chain around the whole thing, attach it to the telehandler, see if the house falls down.
To find out if this wall carries the structural load of the house, the team is wrapping the wall with a heavy-duty alloy chain that has a workload limit of 8,000 pounds. The maximum weight it can pull before it snaps. When the telehandler shifts into drive, it should pull down the wall completely.
Got it?
Okay.
If it's a load-bearing wall, it could also pull down the second floor.
We're hoping to rip this wall clean out. So we put 1 chain around the top, and this one goes all the way out to the telehandler.
All right, chain is coming through.
Believe it or not, people rig similar systems to their pickup trucks to do exactly the same thing.
Chain's good.
All right.
Now all Brendan has to do is step on the gas.
Ready?
Yeah, do it.
But before they find out whether removing this wall will bring the whole house down, Brendan and Francesca want to show you how one piece of your furniture might be trying to kill you. Everyone has a drawer full of junk somewhere in the house to stash those unsightly dust collectors that don't have a place of their own. But as Brendan is about to show you, it's what's inside your junk drawer that you really have to worry about.
Let's see what's in here. We got some matches, a cat toy, some paper napkins and some candles, some lighter fluid. This is pretty standard stuff. But this one small 9-volt battery could change that in an instant, turning this into a real home hazard.
What makes 9-volt batteries so dangerous are the unprotected posts. One gives off a negative charge, and the other a positive charge. When these posts come in contact with the thin iron strands in this steel wool pad, it completes a circuit of electricity, sparking a fire that is fueled by the air that flows inside the fibers. Brendan wants to show you how keeping a 9-volt battery and flammable household liquids in the same drawer can leave your home in ashes. He's tied a fishing line so he can remotely pull the battery into contact with the steel wool, mimicking the motion that happens when a drawer is opened and closed.
The drawer's now rigged. All I have left to do is drop in this fan for a little air movement, pull the string, and we're ready to go. You ready?
Ready.
Right on, okay.
Brendan has rigged a 9-volt battery to some fishing line and has placed it in a drawer containing steel wool, lighter fluid, and some napkins, the kind of junk most people have stashed in a drawer somewhere in their home. Now he wants to show you how this can result in a potentially deadly fire.
Well, we have a fire.
That's a hazard.
That's a pretty good fire, and you wouldn't know it was burning.
So it's a matter of time before that fire catches on
to a bigger object, and then your whole house is at stake.
It's easy to see how this fire could quickly turn your wooden furniture into a much bigger inferno.
Unbelievable.
Brendan has shown that what you put inside your furniture can start a deadly fire. But Francesca wants to show how furniture tipovers cause serious injury to more than 14,000 Americans every year. And most of these accidents happen to children. Let's say your child wants to retrieve this stuffed dog that's been placed on top of our freestanding hutch. Now, Francesca will try to find out what it would take for a toddler to bring this whole thing down.
A child is going to try and find a way to get up to the toy. What are they going to do? Probably pull out a drawer and use it as a ladder. Reach up for the toy, and the whole hutch comes crashing down on top of me.
She's rigging up a pull cord to the hutch and attaching it to a scale that will measure the pounds of force exerted in the pull.
I'm putting as much force as I can, and in this case, I got to 25 pounds.
These may look like ordinary stuffed penguins, but trust us, they're not. These stunt doubles have been modified to demonstrate what a falling hunk of furniture can do to the internal organs of a small child.
Okay, 3, 2, 1.
Oh! Well, that worked. How hard did you pull?
It really wasn't that much.
It wasn't. Less than 20 pounds. So that's not a very big kit.
This hutch weighs more than 250 pounds. Tipping from a height of 6 feet, it delivers an impact force of 1,200 pounds. Enough to break all the bones in your body.
Let's find our penguins.
Hold on, you ready? Oh, there he is. He feels a little broken.
Oh, man. Devastating injury.
So is that his internal organs? That's pretty bad.
Completely split open.
These broken watermelons only hint at the true damage this falling hutch could have done to real children.
The entire weight of the hutch landed on the penguin's torso and head. It took 20 to 25 pounds of weight to make this hutch come crashing down. That's not even the size of a 6-year-old child. People either need to anchor their furniture to the wall or really show their children that this is not something to be played on.
I think that as much as my junk drawer was cooler, this is a bigger hazard. All right, well, I'll give you this, Frankie, because this is dead penguins. Ready?
Yep, do it.
The hazard team has rigged a chain around this wall and has hooked it up to the telehandler outside, all to recreate what could happen to your house if you accidentally take down a load-bearing wall during your next do-it-yourself project.
Nice and easy. Oh, something popped. Oh, we're slowly sandwiching the wall together. Right, we're definitely getting some of that wall out now. Oh! You're starting to shoot through the window! Oh, yeah.
Windows blown out. The wall looks completely messed up. Let's go check it out.
Ooh.
No way.
Great. We ripped out the wall, but there's a support beam in the middle.
Sunk directly into the concrete below, this single column is providing support for nearly a quarter of the house's structure.
But this thing goes from the foundation in the basement all the way up to the roof.
I don't know if the telehandler has the power to take this beam out. So, you gonna move the bulldozer?
Yeah.
Can I drive?
No.
Now the team is trading in the telehandler for something with a bit more moxie.
When the going gets tough, the tough get a bulldozer.
All right, Frankie, we're ready to go.
The tracks on the bulldozer grip the earth better than the wheels on the other machine. They hope this grip will give the team the horsepower needed to pull out the support column. That is, if the chain can take the stress.
Keep going, keep going, keep going, keep going. Keep going, keep going. Oh, chain snap.
Chain broke. Oh,
Hold it
stop
right
it,
there,
just
Frankie.
cut it.
Luckily, Brendan and Dan were nowhere near the chain's violent snapback. At such a high velocity, this 40-pound chain could have killed them both.
All right, guys, that pole hasn't budged an inch, and look what it did to our chain. This is rated for 8,000 pounds. And if that pole's cemented down, it's probably like upwards of 20,000 pounds. We have a better chance of bringing down the house by attacking the exterior walls.
I really underestimated that post. I thought for sure we could take it down with that chain. No, let's just take down the rest of the wall.
Okay, attack the exterior walls.
Without a chain strong enough to pull out the column, the team is switching their focus to an obvious load-bearing wall that still gets demolished by amateurs with disastrous results. They're going to find out what happens when you knock down the exterior walls. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The backyard barbecue. Summer isn't the same without it. But given that charcoal barbecues cause 7,900 fires every year, you want to make sure you're still alive by the time your sausages are ready to eat.
Barbecuing has got to be one of the best parts of summer.
Absolutely.
I'm going to assume that these are done.
The reason for caution? Charcoal is typically first soaked with an accelerant because the briquettes can't light themselves. And Dan has the most popular type.
Lighter fluid is volatile and obviously very hazardous. That's why you're only supposed to use a little bit. The only safety on this thing is pretty much the cap, which is designed to prevent you from adding too much of it to your fire. Now I'm about to do two things you should never, ever do. One, add fluid to a lit barbecue. And two, do it from a bottle that doesn't have a cap on it.
Just like a trail of gas lit by a match in the movies, when Dan begins pouring, the flame can travel up the stream and back into the bottle.
You see, the fire traveled right up the stream and into the bottle. This is extremely hazardous. Thanks.
But Francesca's brought her own brand of canned heat to the party.
Dan's combination of lighter fluid and a barbecue was incredibly dangerous, but so is this. Flame source and aerosol sunscreen. Check it out.
Francesca's aerosol sunscreen uses alcohol as a propellant. And as you can see, alcohol accelerates an open flame just as dramatically as Dan's lighter fluid.
That is a hazard.
Now, they want to show what happens when you mix these two products together in a perfectly plausible way. They've invited a few friends over, who gather round the barbecue. In order to prevent a sunburn, everyone applies generous amounts of sunscreen. But little do they know, they're being set up for a much more severe scorching. The final factor? An open flame, which Dan and Francesca will trigger remotely.
Let's barbecue.
Count it down.
3, 2, 1.
Oh no!
There you go.
In seconds, they are completely covered in flames.
What's ironic about this is that you actually put on sunscreen to prevent a burn.
Oh,
you
a
made
third
a-
one.
Go!
Oh!
Let's put this thing out. This is making me rethink sunscreen entirely, especially while I'm barbecuing.
I will never apply sunscreen close to a barbecue ever again.
In an attempt to demonstrate the perils of improving your home without the proper know-how, the team has been attempting to remove a load-bearing wall. But so far, the house hasn't given in so easily.
We're slowly sandwiching the wall together.
Fighting back by snapping their chain. So the team is switching to a more over-the-top load-bearing removal. The exterior walls.
All right, how are we gonna bring the wall down?
I think that we can't just wrap the chains around it the same way we did last time. The wall's just gonna collapse in on itself. I think it'd be cooler if we took the whole wall down at once.
All right, so let's give it a little bit of structure, like a frame.
I've got a metal frame. I use it for some other stuff. We can run the chain through it, pull out the whole section at once.
Nice.
The exterior walls on a house are almost always load-bearing.
Hey, Brandon, I'm through!
They're placing this frame against the studs of the wall inside and rigging it to a new set of chains, distributing force across the width of the wall and up the support structure of the second floor.
You got it?
Yep, I got it. Our approach here is not that elegant. We've literally wrapped the wall in chains, and we're gonna pull it with a bulldozer.
I'm ready to go.
If their plan works, they should be able to take down the wall in one big chunk. Amazingly, the house still stands. But for how long?
I think if we take out the rest of that corner, the entire thing's gonna come down.
I think we have to do it with the telehandler because no one can get safely anywhere near that with that load-bearing wall just balanced up there.
Our house is still standing, as is that room. So Dan is gonna grab the telehandler and we're gonna punch out what we think is the final load-bearing wall.
Hot tubs can be a luxurious escape from a hectic world, but they're far more nefarious than they look. In the last 20 years, they've sent more than 90,000 people to hospitals and killed dozens more.
I just got out of a nice warm tub, and now I have to drain the water. But why drain it out when I can blow it out?
When hot tubs explode, it's normally due to malfunctions in their heating systems, which are often fueled by natural gas. When an open flame meets flammable pressurized gas, the possibility of an explosion always exists. It might be a freak occurrence, but no matter how rare it is, you probably don't want to be bathing when a propane heater springs a leak. To demonstrate how dangerous this can be, Brendan has submerged a gas bomb and has rigged a remote ignition system to recreate what that hazard looks like. Now that's what you call totaling a tub.
Ready to go.
The team is recreating the hazards of a do-it-yourself demolition on a load-bearing wall. They've tried to bring down the house from the inside, but they've switched focus to something more obvious.
Come on, Dan, hit the gas!
Now Dan is behind the wheel, ready to remove a corner of the house's exterior support. The first floor wall is completely gone, and yet the house is still standing.
Come on, Dan, that last corner, just tear it out!
But the structural damage has turned their home into a disaster zone.
Still standing!
A little higher, Dan.
Higher, higher!
Dump that stuff off the forks. What is holding that up?
Dan, whatever it takes to bring this down, just go for it.
Finally, the load gives way. If you're going to do it yourself with a load-bearing wall, let this be a lesson in what not to do.
Oh, yeah! Oh, it definitely opens this place up. This is hazardous, mainly because it's so unpredictable. We had no idea what it was gonna take or when it was gonna give.
The destruction behind me should give you an idea of how important it is to appreciate load-bearing walls. If you knock those out, this is what could happen.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
3, 2, 1!
Nature's fury is unleashed. Floods, hail, fire, and even snow. The team is braving the elements and the hazards they cause. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Over its lifespan, a house will face all different kinds of hazards, and this house has seen most of them.
That house is in rough shape.
But while we can prevent many of these disasters from happening, others are in the hands of Mother Nature, and it's up to us to protect ourselves as best we can.
Ready?
Yeah. Bring the platform in right above the buckets. Brendan, I'm in the tree right now. Can you try to negotiate a little better, please?
Today, the team is going to test how well we're protected from two hazards that together cause over $10 billion a year in damages.
Easy does it, Brendan.
When Mother Nature wants to be, she can be very hazardous. From tornadoes to earthquakes to avalanches. But today, we're gonna see which is worse, a hailstorm or a flood.
First up is a hailstorm. Hail forms when ice from storm clouds begins melting into rain. If an updraft of wind draws it back up, it refreezes, adding an extra layer of ice, creating the hailstone. As this cycle of thawing and refreezing repeats itself, the hailstone grows until eventually there are large chunks of ice falling from the sky. To demonstrate the trouble that a hailstorm can cause, Francesca's planned a full-on assault. Dan and Brendan will be firing a pair of high-powered industrial vacuums filled to the brim with salt rocks, simulating the average hailstone. On the telehandler, 2 air cannons loaded with dozens of golf balls have been rigged to launch directly at the house, replicating a very destructive hailstorm. And finally, Francesca's gearing up. She'll be shooting frozen paintballs out of a semi-automatic .50 caliber paintball gun.
It'll simulate about the same speed and impact that quarter-size hailstones would have.
Her target is the front of the house, complete with glass door and awning.
The awning is made out of the 3 most common roofing materials: aluminum, shingles, and vinyl.
The roof is our first line of defense against the elements, which means it's also the first to get damaged. The team wants to know which material can withstand the hailstorm best and which one will cost insurers the most.
Okay, go for it.
Hailstorms are rated on a scale ranging from 0 to 10, based on the size and speed of the stones, plus the storm's intensity. A storm with a rating of 10 can last for hours, and Francesca doesn't have enough golf balls for that. So instead, she's going to deliver a combination of a 2, 3, and 5 rated hailstorm all at once.
That was beautiful. It was like
Hailstorm.
violent Christmas snow.
Even though Francesca's paintballs were small, they were traveling close to the top speed a hailstone can reach, almost 200 kilometers an hour, easily breaking through the glass door.
You took care of the door.
I did, didn't I? And the windows.
Meanwhile, traveling at an average speed of 32 kilometers per hour, the larger salt rocks proved no match for any of the roofing materials. But then, there were the golf balls, traveling at 120 kilometers an hour with a collective weight of 7 kilograms.
Definitely a lot of damage. The vinyl stood up pretty well. The asphalt shingles look pretty good. It's the aluminum that is really, really banged up. This awning has seen better days.
I appreciate why you wanted to do this. It demonstrated hail well, but mine's much more simple, and it's much more destructive.
Brendan's test takes 200 lives every year and is the leading cause of weather-related deaths in North America. Behold, the flash flood. A flash flood occurs when heavy rains dump so much water, it's impossible for the ground to absorb it all. The remaining water accumulates, rapidly flowing downhill, often in the path of houses, which Brendan is about to demonstrate.
I've got 3 dump tanks up here. Each dump tank holds about 100 gallons of water. So when I pull them all at once, I got 300 gallons of water aimed straight at the front door.
Into the tanks, Brendan adds another ingredient to the potential watery devastation: debris.
It's the kind of stuff that would actually get picked up during a flash flood.
During a flood, large objects such as these are propelled by the force of the water, ramping up the damage. It's all aimed at the house.
Are you guys ready in there?
All right, bring on the flood.
Flash floods arrive without much warning, with the storms often miles away from the flood path. And just like a real flood, anyone still inside this house would have no way of knowing that hundreds of gallons per second were about to be unleashed on their front door.
All right, here we go. And 3, 2, 1, go!
This is like 300, 400 gallons just devastating the house.
And this is when it came to a full stop. Imagine this was a real flood. It would have kept coming and coming and coming.
If this were your home, there's almost nothing you could do to prevent this devastation. A flash flood like this could lay waste to your entire house. And even worse, you'd have almost no warning before it happened.
What do you think?
This is absolute destruction. Francesca's hailstorm looked spectacular, but it didn't really cause much damage. Brendan's flood, however, wreaked havoc on our door, on our front entrance, and on our basement. In the battle of hail versus flood, I gotta give it to flood.
Under the hot sun, the last thing you'd think of is a snowstorm. But snow can be your house's worst enemy. Catastrophic winter storms strike North America every year, causing over $700 million in damages. And most of it impacts the spot right over your head.
Today we're testing to see just how hazardous it is when too much snow collects on your roof.
Most roofs are designed to support a snow load of 50 to 100 kilograms per square meter. However, a winter storm is often accompanied by strong winds that can cause snow to drift, creating isolated accumulations that overburden the roof structure.
We don't have a snowstorm today, but what we do have is gravel and a huge conveyor belt.
Okay, bring it in.
At more than 2.5 times the weight of snow, the team shouldn't need much gravel to cause a breach. And by using the conveyor belt, they'll be able to focus it onto one spot, replicating a roof-busting snowdrift.
Okay, go, good, that's good.
With everything in place, Brendan starts the snowstorm.
Take it easy, go slow.
As they get older, most roofs develop weak spots, and it's here that the team is aiming the gravel. If the roof is going to collapse, this is where it will happen.
The front here, where all the water's pooling, that means that our roof has already started to bow. And that's exactly where we want our gravel to land.
The pile has almost reached the equivalent of 1 cubic meter of snow. Including the weight of the water, this is well past the 300 kilogram per square meter capacity of the roof. But the house has yet to creak.
And... guys, this is not working for us, all right? Those beams up there are double joists, and they run the entire span of the roof.
Built like a tank, this house is putting up a fight. If the team wants to simulate a real disaster, they'll need to focus their assault on the inside. But before they do, Dan has another winter remedy that might cause more harm than help. The space heater. Like a little fireplace, it provides supplemental heat throughout the long winter nights. But just like its flame-filled counterpart, this thing's also a killer. 54 times more likely to be lethal than a central heating system.
Whenever you've got a heating element with combustible materials, there's potential for hazard.
A space heater uses metal coils to convert an electrical current into heat. As the coil charges up, it radiates that heat, and a fan behind blows the hot air into the room.
Space heater's been running for about 20 minutes. To the naked eye, it doesn't seem that hot. But when you put the thermal imaging camera on it, you can tell the coils are above 340 degrees Celsius. Now the obvious hazard. What happens when the space heater gets knocked over? It turned off because every space heater has built-in safety mechanisms. To show you how truly hazardous this can be, I'm gonna have to disable them.
New space heaters come with 3 different safety features. A grate, which keeps objects from touching the heated coils. A tipping sensor, which uses gravity and a counterweight to interrupt the power if the space heater is not standing vertically. And finally, the thermostat, which keeps the heater from burning things up.
This is the on and off knob, but it also has a built-in thermostat. That's why I have to take out the entire thing in order to make this work. With the modifications I've made to this space heater, it's become a real hazard. So to show you a real-life scenario, I've modified 2 more. It's not uncommon for people to use multiple space heaters in one room, and they often put them in very unsafe places. Whoops.
With the malfunctioning heaters now inches away from the highly flammable bedroom materials, Dan has created quite the fire hazard. Exactly the circumstances for a bedtime inferno.
One less fan.
It doesn't take long for things to heat up.
Oh. Oh. The bed is officially on fire.
Just 5 minutes in, the overheated coils burn out the fans, but the hazards are far from finished.
The carpet one's making a lot of smoke, but the only fire we got is coming out of the bed.
Not only has the fire erupted out of control, but the fumes coming from the nylon carpeting, polyester curtains, and cotton comforter are creating a toxic mix, just as deadly as the fire itself.
I'm gonna have to put this stuff out.
Let's not forget, the coils are still red hot.
Whoa, hey there. Oh, am I?
It's clearly time to pull the plug.
It's making really black smoke. I'm gonna put it out. Hey, this one's out. Hey. I'm not picking around here. All right, get out. Oh my God, look at that smoke. There was a lot of smoke in there.
A heater might be designed with safety in mind, but it only takes minutes for a malfunction to become life-threatening.
The worst part about that fire is that it didn't make a sound. So if you were sleeping in that room, you would have been dead in 10 minutes.
Maybe this winter, try adding another blanket instead. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program.
Keep it going. Okay, cool, good, that's good.
The hazard team is putting aside the fact that it's summer to test how much snow it takes to collapse a roof. Using gravel, they're simulating a snowdrift buildup that's heavier than the average load capacity of a roof, 300 kilograms per square meter. But so far, it's holding strong.
Those beams up there are double joists, and they run the entire span of the roof.
Whatever your climate, there are two basic types of roof construction. The pitched roof has a slope of 10 degrees or more. Once the snow load reaches a certain level, it will slide off under its own weight. The flat roof, however, needs to be much stronger, as the snow has nowhere to go, allowing for larger buildups that could be catastrophic. To compensate, builders sometimes reinforce these roofs to ensure they can withstand the extra force. Exactly why Dan suspects the roof is still standing.
Brendan, cut it, all right? Francesca, cut it. It's not working. Cut it. This is not working for us, all right? Nobody makes things like that anymore. They're way too strong. We're gonna need to compromise them.
That could happen in a real home. Poor carpentry, no maintenance.
Yeah, maybe there's a leak in the roof and they start to eat away at your beams. So we're gonna have to get in there. Let's go.
With so much weight on the roof, going inside the house is a real hazard. So the guys have suited up and will only be making the minimum amount of changes necessary to simulate poor maintenance in a normal home. Once compromised, it's impossible to know how much snow a roof can support or for how long. And the guys don't want to find out the answer until they're back outside.
Do we do any more or do we go?
Let's do these two more and then we're good.
Dan! I think I can hear creaking.
With the joists weakening and 360 kilograms of gravel sitting on top, it's time for the team to get out of the building. But before the experiment can start back up, there's one more cold weather hazard Brendan wants to show you. When the temperatures plummet, many of us forget that our houses feel the effects of the cold as well. All it takes is a small crack in a water pipe, and as much as 950 liters of water a day could be seeping into your home. Something 250,000 families experience under the harshest winter conditions every year. Allow Brendan to demonstrate.
Metal pipe filled with water. Liquid nitrogen. This is what happens when your pipes freeze in the winter.
At minus 196 degrees Celsius, Brendan's using liquid nitrogen to accelerate the freezing process of a harsh winter night. In only a few minutes, the liquid nitrogen freezes the water trapped inside the pipe, which rapidly expands by 9%. And the result?
So you see that? You see the crack? That's what happens to solid cast iron when it freezes in the winter. It cracks your pipes. That's the power of the frozen water in your pipes.
Cracked pipes on average cost homeowners $6,000 in repair bills. But it's easy to avoid by insulating the pipes, installing heat tape, and even letting a tap drip on an extra cold night.
Now what do I do with all this liquid nitrogen?
Liquid nitrogen is a cryogenic fluid that boils at minus 196 degrees Celsius. Anyone can buy it, and it's used in everything from science projects to preparing gourmet cuisine. But don't underestimate its danger. This stuff can cause severe frostbite when exposed to skin. But Brendan wants to show how this cold substance can actually create a miniature weather system. When nitrogen hits the pool, its extremely low temperature causes the moisture in the air above to condense into clouds, forming a tiny tropical storm in the pool. Having weakened the joists, the team's 360-kilogram artificial snowdrift could collapse at any moment. But Mother Nature can still make this scenario a lot worse. Over a long winter, the hazard created by the team could easily sit undetected for months, weakening the beams further with each passing day.
Nice, guys. It's looking really good.
If another storm were to hit the house, it could be a family's worst nightmare. But the team's going to show just how bad a winter can get. On average, a city in North America suffers 5 winter storms a year. And while a roof may be able to take 1 or 2, unless the snow is cleared or allowed to melt, the weight will keep building.
Just keep going like that, guys. It's perfect.
Already past its maximum load limit, there's no way to tell if or for how long the roof will last.
Whoa! Guys, we are starting to have a collapse. The water is draining. It's important to remember that gravel is about 2.5 times denser than snow. So this represents a much bigger pile, but it still didn't take that much to start the roof collapsing. It's not completely down, but it's dropped a good 2 feet.
All the water pouring in.
Pouring through.
Make no mistake, the breached roof is already a hazard, exposing the house and anyone inside to the severe cold of the winter. But nature can be very unforgiving, with snowfalls lasting for hours and hours. And so with that in mind, the team continues adding to the load.
Guys, I'm hearing some creaking.
With the equivalent of 3 cubic meters of snow on a single spot, it finally gives way, completely destroying one side of the house. While a hazard like this can be avoided, without proper roof maintenance and regular snow clearing, you could be left out in the cold.
What most people don't realize is if you have a flat roof and there's a lot of snow accumulation, this can be the end result.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards. Chemical spills lead to big thrills in the gardening shed. A table saw takes a slice out of life. And the pressure builds
I feel like it could go any second.
on what's left of the house. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Hot water. It's one of the basic creature comforts that North Americans enjoy. Imagine taking a bubble bath without it. But this seemingly magical technology is not without its dangers.
There's a hot water heater just like this one in every single home.
Improperly maintained, a heater can equal the explosive force of 10 sticks of dynamite, making it the most destructive appliance in a home. And this home knows destruction. It's hard to imagine that something found in everyone's home could be this destructive, but the hazard team wants to show you how it could happen. A water tank is really an airtight pressurized steel drum, insulated from the outside to keep it warm inside. That heat is generated by two elements, which transfer energy to the water, warming it up to a set temperature.
If we have hot water under pressure, that's a pressure vessel. And anywhere where we have a pressure vessel, that's a bomb.
But it's got a lot of safeties built into it.
If we compromise those safeties, can we make this thing explode just based on that?
The main safety mechanism on a water heater is in the thermostat. To stop a violent pressure buildup, each thermostat comes equipped with an ECO, or energy cutoff. If the temperature inside the tank gets too high, the ECO will shut off the power, allowing the tank to cool before a violent explosion can take place.
Our water heater has two elements, and therefore two thermostats, one on the top and one on the bottom. If I bypass the thermostats, our elements will just stay on, making the water hotter and hotter and hotter until this thing blows up.
And that's exactly what the team wants to try out. With a little wire splicing, Brendan is replicating a failed thermostat.
So we can keep track of what's happening inside the tank, I'm gonna install a pressure transducer that'll measure the pressure inside the tank, and I'm gonna install this temperature probe right between the insulation and the tank. That's gonna tell us how hot the tank is getting and about when it's gonna blow. Yeah, looks good.
With the safety devices removed, the temperature is now free to rise without stopping. But it's impossible to tell exactly when the explosion will happen. It could be hours. I just don't know. Explosions such as this one have been known to launch debris up to 800 meters, which means the team needs to be protected if they want to watch. Before going into lockdown, Brendan set up a home hazard experiment with teeth. Of all the power tools a homeowner cherishes the most in his workshop, the table saw is often the most widely used, but it's also dangerous.
Most people are incredibly afraid of operating a table saw, and rightfully so.
Nothing cuts a board quite as cleanly and efficiently as a table saw. But then again, with 31,000 injuries treated in U.S. emergency rooms each year, it seems to cut through human flesh effectively as well. How could someone end up putting a hand into a table saw blade? There are all sorts of reasons for human error.
People are tired, people are rushing, people just have a break in concentration for half a second, and they lose fingers.
A table saw spins a blade at high speeds, which extends from the middle of a flat table. In order to cut material, it must be pushed away from the operator, using a fence for guidance.
Allow me to show you firsthand how fast the devastation can happen.
The most common injury received from a table saw is to the hand, with 10% resulting in amputation. And rather than donating his own digits, Brendan has filled a latex glove with chicken meat and bone, which he'll push into the blade, simulating a disfiguring accident in the workshop. Even though bone is more than twice as strong as wood, the saw still slices through it like a knife through butter. If left unattended, this injury is so severe, the blood loss can cause death.
If this had happened to me in real life, I'd be on my way to the emergency room, with half my hand in a bucket.
Brendan's shown the devastation a table saw can cause to a hand that gets caught in the blade. But that's not where the hazards end with this machine.
Another thing to consider when you're using the table saw is that you're not always cutting a brand new piece of wood. The wood might be old and have imperfections, it might have a knot in it, and sometimes it might have a bolt in it.
Spinning at 4,800 revolutions per minute, the table saw is capable of cutting through the bolt, but it can easily become an unpredictable scenario where the wood could shift or even split. So, to protect himself, Brendan has added a piston to the table saw, which will allow him to operate it remotely.
Now I'm going to engage the piston and send the piece of wood with the bolt through it into the saw blade. The head of this bolt was sheared off and forced down into the block of wood in just half a second. That shows you how fast this blade is moving and how powerful this motor is. but that's not where the hazards end with a table saw.
And with a motor this fast, it's not the only way wood can go airborne. In fact, one of the most deadly hazards an operator can face is something called kickback. Kickback is when the wood is pinched between the saw blade and the fence. If the piece of wood is at an angle and catches rather than cuts, the blade transfers its torque to the wood, shooting it back from where it came.
I'm going to turn the saw on. While the blade is spinning, I'm going to engage the piston, which will push against the board, getting it to run against the blade. That will definitely give us the most violent kickback.
Unable to find a willing volunteer, Brendan is setting up a piece of glass to take the hit, demonstrating the force that could be delivered to a human operating the machine. The saw is on, the board is in place. Now all he has to do is engage the piston. Traveling at a breakneck 440 kilometers per hour. Once the blades catch inside the wood, it's turned into a lethal projectile. The more teeth that catch, the faster the wood kicks back. If this were to hit the chest or abdomen of a person operating it, it could break ribs, puncture lungs, and in the worst case, kill.
The most important thing to remember when dealing with a table saw is that if you do not respect the tool and the dangers surrounding it, then it will not respect you. And that will most likely lead to a serious injury.
Regardless of how dangerous a table saw may be, at least you have a chance at survival. With a water heater, the odds are definitely not in your favor. In an effort to recreate the devastation of a water heater explosion, the team has disabled the thermostat, allowing the water inside to heat up beyond its safety limits.
Looks good.
It's nearly an hour into the experiment, and they still don't know exactly when that explosion will happen.
I've hooked up both the pressure and the temperature sensor to this recorder here. Now this is reading live what's happening inside of our tank. I've also hooked up the recorder to this computer so that I can watch the history of what's taken place. These are our temperature trends, and this is our pressure trend.
As the temperature rises, the water will turn into steam, expanding up to 1,700 times its original size. But with an airtight tank, the steam has nowhere to go, forcing the pressure to build up instead. Only built to withstand 300 psi, if the pressure passes this point, the tank will have no choice but to eventually explode.
Here's the trouble, all right? We're getting up to 140 degrees Celsius. There's no problem with the temperature sensor, but here is the pressure sensor.
Why is there no change in the pressure?
I don't know. Maybe it's a trouble with the actual sensor itself.
Can we go in and check?
If we do, we have to go really quick and we have to go now.
The team has no idea if it's the water tank or the pressure sensor that's malfunctioning. Luckily, with only a few minutes having elapsed, it's impossible for the pressure to have reached lethal levels.
There's water everywhere.
With the water already boiling inside the tank, a pressure release valve on the heater is kicked in, letting out the trapped steam, keeping the pressure from building up.
That's why we weren't getting any readings.
All the pressure was let out of the tank. If we plug this thing up, there should literally be nothing that can escape this tank.
This release valve is an added safety mechanism that ended up working this time. But in poorly maintained heaters, mineral deposits often clog these valves, the main cause behind a tank turning lethal.
Hold on.
With the water temperature already beyond its boiling point, it shouldn't take long before the plugged safety creates the pressure buildup the team is looking for.
Perfect. See, now we can start to see the trend. You can see the pressure gradually going up.
Perfect, so that was the problem.
Yeah, and our temperature is now up above 170 degrees Celsius.
Perfect.
All the team has to do now is wait for the lethal results. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The garage. Most homeowners have one, and if you do, you probably went to the trouble of installing an automatic garage door. But garage doors seriously injure more than 20,000 people every year. Now, Brendan wants to show you how an accident could happen to you.
I'm gonna test the crushing power of the garage door.
The average garage door opens and shuts 1,500 times a year, but is only rated for a total of 10,000 cycles. That means a 7-year-old door is well past its prime and safety mechanisms could be compromised.
The only real safety mechanism on your garage door is this. This is the optical sensor. It sends an invisible beam of light from one side of the garage door to the other. If that beam gets interrupted, it stops the garage door from lowering.
Now, Brendan wants to disarm these safety sensors, replicating what would happen if they'd been improperly installed or broken. He's also removing the protective rubber strip, which can wear through after years of use, exposing the metal that gives this 90-kilo door a cutting edge.
Playing the part of our crushing victim is Mr. Donkey Piñata. And if we're gonna break open a piñata, we might as well have candy.
Frankie, ready?
I'm ready. Is our piñata ready, though?
He's not ready. That's clearly the point here. All right, here we go.
This piñata is just a stunt double for any child or pet caught in the wrong place at the wrong time.
On garage door! Goodbye, piñata!
As the sensors fail, 90 kilograms of door crush through the piñata's spine. That's what you call a el peligro de la casa.
All right, I'll take that half.
No.
His guts are good, though.
Brendan's door-crushing test has squeezed the candy right out of the piñata.
Why did you crush me, Brendan?
I'm sorry, piñata Francesca. It was just, today was your day.
Francesca thinks she can make a much worse hazard out of this garage door opener.
This is the idea. Somebody goes up a ladder to check on the chain drive. You're looking around. You're unaware of the fact that a piece of your hair has gotten caught in the chain.
A garage door opener typically uses a 3/4 horsepower motor to pull a bicycle chain back and forth, opening and closing the garage door. Once engaged, they're impossible to stop unless something passes the optical sensor. To demonstrate, Francesca is gluing a full head of hair to this dummy to show what would happen if you got your hair caught in the opener's drive chain.
It's caught up in the chain. All right, looks good to me.
You ready?
All right, go.
Oh,
Once engaged, the opener is ripping the mannequin's hair with the same force as his small stallion. And worse still, having lost her balance, the mannequin is now dangling a meter off the ground.
Oh, look at her.
Chunk of hair.
Well, that would have hurt.
That was a horribly morbid situation. It grabbed the chunk of hair, sucked it into the gears, and when it couldn't suck any more hair in, it just tore a clump out and she crashed to the ground.
The other thing is, if it hadn't ripped out of her head, she'd be stuck up there with that motor until someone came in to free her.
Oh, that's a horrible thought. Don't. That makes my head hurt.
In the battle of chain drive versus garage door, I think the chain drive wins.
Now that's a bad hair day. But it's nothing compared to what's been unleashed in the basement. The team has compromised the safeties on their water heater in an effort to show just how destructive this essential appliance can be. If everything goes as planned, the heater will explode at close to 900 feet per second, about the same speed as a 9mm handgun. Except this will be a much larger bullet. Inside the bunker, the team has been waiting for more than an hour, and all they can do is study the numbers.
We're at 180 degrees Celsius, but we still have a long way to go for pressure. It's anybody's guess when it goes.
Even though a tank is tested up to 300 psi, it's only meant to carry 150 psi. And if there are any weak points in the steel tank, it could rupture early, making it too dangerous for the team to leave the bunker. Completely locked down, there's nothing to do but wait and see what will happen.
What do you guys think is gonna happen?
I don't care how high the tank goes, I just want to see that force knock down all the walls and maybe even bring down the second floor.
I'm hoping it shoots straight up beyond my field of vision.
As the minutes tick by, the team settles in, unsure if and when disaster may strike. Having a beautifully landscaped home can increase its value by 12%, but all those gardening products come with a hidden cost. Your typical garden shed is filled with hazardous materials, and if you don't store them properly, you might get a real bang for your buck. Leaving these toxic and volatile products exposed to water leaks or even animals is a very bad thing. It only takes a few spills and a match, and you could have yourself a genuine fertilizer bomb. Just steps from your house.
Chemicals plus open flame plus closed door means Brendan gets a new shed.
This explosion produces a pressure wave that travels at the speed of sound. It's clearly strong enough to kill someone standing nearby.
Goodbye, shed.
Brendan, Dan, and I have been in this bunker for over 3 hours now. It is minute-to-minute stress. This could go off at any second.
It could go before the 300 PSI, couldn't it? Possibly?
Agreed.
Inside the house, the team's malfunctioning water heater is building up to what could be a home-destroying explosion. But outside, things are moving slowly.
Like it's just a big bed right there.
After 3 hours, the team is getting bunker fever.
The reality is that we can't leave until it goes off. I'm sweating, I'm exhausted waiting for this thing to go.
Still, all the data points to an imminent disaster.
We've just hit 200 degrees Celsius. At this point, the pressure's gonna start climbing exponentially. This is serious business.
At 200 degrees, the tank is now closing in on the limit it was tested to by the manufacturer. And with each passing second, the pressure inside is growing faster than ever before. It could blow at any moment. Beyond 300 PSI, the tank is now containing more heat and pressure than it ever has before. It's like lighting a bomb, but you don't know how long the fuse actually is.
Finally!
Look at the steam rising out!
The whole house is gone.
Oh my God, I've been waiting hours for that. That's beautiful. I'm so glad.
The longer we waited, the bigger the bang got.
Reaching a total of 351 PSI, the steel could no longer contain the intense forces inside. It's absolute devastation.
Look at that! It just opened up like a can of beans!
That's awesome.
The other wall's also gone.
It looks like it was cut in half. Imagine we were in there or anyone was in there. This is devastating.
Oh no, you'd be dead.
The shockwave alone would liquefy your insides, let alone the shrapnel.
I felt that shockwave inside the bunker, 250 feet away. That's bad.
This is something that people really need to pay attention to and maintain their water heaters.
We just saw how powerful and how destructive a water heater can be. And there's literally one in every single home. These kinds of accidents happen all the time. But it's also the perfect way to illustrate home hazards. The force that came out of that thing ripped through the walls. There was nothing that could stop it. This was one final house hazard to bring down the house.